DS regex. Um, or you can say struct.py. Okay, we have some more. Who need those trees? Mm, actually don't need the All right, everyone. So it's time to optimize the underlying concept of the rendering mechanism for this plugin. Previously, our approach is kind of correct, but we are abstracting the data too much, and that's why we are overcomplicating the code. Let me show you guys what I really mean that uh, Excalibur. So should I pop up that thing here? Okay, so let me explain you guys. Anyways, I can put one here. All right, so I can abstract this thing here, and this one should go here, and something like that, and that should do it. Right. Or Control Shift N. Okay, that was nice. So let's close this one and push this thing here. And there we go. So now we have a good setup for the chat. Okay. So first of all, let's enable the dark mode and okay, let's start drawing things. So let's see, we have tree. So previously we have a tree, same, which have some children's. So if I take this here and here, so suppose this is the root, we can write it as root. This is the this is the child one and child two. And let me point some arrows to here, and that's it. And here to here, that's it. So this is kind of the overall structure that we are using in our plugin previously, but and every node has some some kind of a data in itself. Like every node has I think 4 keys. Every node has 4 keys. One is name, path, the meta key, and the type of the node, like it is a directory, symlink, or a file. But uh, in before the stream, I'm just thinking about the underlying concept of this rendering mechanism, and I thought, why we have these kind of you know uh, nodes? Like we don't need this much of data on every node, because every node can be distinguished by the the meta key. So if we can just store the meta key in the node, then we can virtually we have the all information that we need by this meta key. So we don't need to handle all of the operation that we need. Like let's say if we want to find a node like child one, and it has name something like package dot json. So if you want to find this node in the tree, then we have to traverse it. And suppose this node is a leaf node in a very big tree, then we have to compare the results ongoing every time, like in the DFS algorithm. And we have to pass a special comparator function which will um, tell us this node is equivalent to what our needs. Because by default tables are not that smart to grab our node, like our target node is like our target node has a name of package json, but by default the Lua tables doesn't recognize that behavior. So we have to add some meta methods so that um, they can use operator overloading concept on comparing the nodes. So we are just moving around that concept. I mean, we just keep aside that concept and just storing the meta key as a node. We don't want to clutter anything in the node. That's why the tree becomes generic, and the can be lower tables can be compared by itself, because the uh, default data types in the Lua can have their own meta methods, and we don't have to pass it. So the will become simpler, and we don't have to abstract anything. So this is the kind of logic that we are implementing in the stream. So you have to just create the tree structure which will hold the meta keys. So let's just make that thing. So filer, this tree structure is much simpler than what we are using before. So let's just quickly make this tree. So tree node. So we have to make a tree node, and what it gonna store that thing like. Let's give a type. It's a filer tree, and the only property it has is the data. So data is just an integer. We don't need to add extra fields to it. But yeah, we need one more field, which is the children. And children is just the integer array. No, it's not an integer array. It's just a filer tree node. So that's it. This is all we just want. And by the way, we can make it optional as well, or we can just leave it like that. To make things simple, we want to pass the children as optional property. So that's not going to be a problem, because if the children's array is empty, then we not going to traverse it. So simple thing, let's just make a module and just return that. And to make a tree, we have to let me just implement that first. So this will return a meta key. No, this will return a tree structure. So let's just create that. So let's return a filer tree. So I think that's all. Now we just have to define the meta key. No, we just have to define the type for this tree. So this is the class. Now we have to define the root. Every tree has a root, so we will assign a filer node to this tree. And I think that's all we need. Now we're going to need a root data. So we just take it as a parameter, and let's uh, give it give it a type of integer. And with this integer, we're gonna use instance table, or we can just return a set meta table. And in this meta table, we will store that data, like data is equals to data. That's it. And there's one more thing, the tree node. So we have to define it also. Let's put it here. Are you using plenary nvim for file handling? No, I'm not gonna using any kind of a dependency. I'm just gonna use a mini dot icons because I want to make things simple as possible. Because if I'm using plenary, then I have to read the whole code base of plenary, like how this thing works. Instead, I'm gonna use a simplistic approach, like I have my own FS module, so I don't need plenary. I can just implement some simple functions to do file system operation. I know this kind of a challenging task, but we can do that. Wrong thing. So we just have to pass the tree node like that. And the same thing for tree index, tree node. By the way, is my voice clear to everyone, guys? I'm not sure. Just let me know if my voice is clear or not. Okay, so we can continue. Annotations specify the return value. #1 has a type of filer tree. Oh, sorry. This could be just tree. That's why type safety is uh, type safety saves you so many times. Okay, so now we have tree. There's not a problem. Now we have to just implement some functions. So let's just implement some methods. Tree. I'm gonna add child. So to add a child, we need address to the parent, right? So let's uh, let's do that. ADRR or ADDR. So this is the address of the node that on which node we want to add this child and the data. This is all we need to add a children to the tree. I mean, this is a simple NRI tree, so not a complex algorithm. We can use complex tree data structures if we need in the future, but currently I just want to complete this plugin, nothing else. So I just so how I'm gonna add the child. So now we have the address. Now we have to traverse the tree. So how are we gonna traverse the tree? So we need a DFS function which can traverse the tree. Okay. Hmm. So should we implement that? Okay, let me just go and if self dot data, um, what? Why self dot data is not available? Okay, 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 got it. If self dot root dot data is equals to the address, then we just need to add the child here. Um, dot root add children. So I need to add the children's here. So wait a minute. We need another function. We need another function for the new node. So we need a new node. Hmm. I don't want to add the new node method, but anyways, we will take care of this later. But now we need to let me just do that thing. So just wait a second. So this is the function for m dot new node, and to new node we need to provide the data. That's it. Okay. By the way, we don't need the tree. We just need the tree node to build up the whole tree, I guess. So we just, yeah, we will just create a node and the whole tree will, okay. Okay, that makes sense. Okay, so we don't need the tree. So this will return a node and this will be a tree node and what is this? Tree. Oh, we have to make it node. Now, if self.data is equals to address, then we're gonna append the childs. So there's one more thing that I have to do. I have to pass an children's array. By default, we have an empty children array, and then we will add children's accordingly. So if we reach to the address, then we gonna self dot children, and we will add the data here. That's it. And if we are not on the correct address, then we're gonna find that child. So self add child, um, add child to the address and the data. That's it. And we have to return. So we have to return early. No. Mm, child in um, I pairs of self dot children do and do. So we will going to so we will go self uh, so this is not the way to add this thing actually. So m dot new data. So we will add the children like this, right? So let's pass it here like that, and now we just have to go like this is a tree node, right? Okay, so this is the tree node. Now we just gonna child dot add child addr and the data. So will this work or not? I'm not sure. Let's try this out. So let's open the tests file, and this is the list. We don't need the list anymore. This is the regex and just test tree.lua. So let's import the test, or you can say mini test test mini test mini dot tests, and we're gonna make a new test set, a new set. So this is the new set, and we return that set, and we will assign some tests to this set. Um, so this will be can build tree. So this is the only thing. Let's tree from actually this is a tree node from the required file struct. So this is the file tree structure, and what we're gonna do is just to make a new node. Actually, let's just grab tree node like this, and we're gonna have the structure. So let's define a structure. So here we have the data. Here we have a data of 1, and we have some children's like data is equals to 2, and the children simply let's assign nothing, and let's have these kind of children's like three of them those children's, and this will be 3, 4, and 5. Okay, so this is the kind of a tree structure for the demo, and we're gonna make this tree accordingly. So let's create a function, local function, build tree, and we will pass a node. So we're gonna pass the node here. So how are we gonna build this tree? We just need to pass the struct, and we will and we will traverse this thing. So um if struct dot children, then if struct dot children, then we're gonna traverse every children. So child in I pairs of children, or you can say struct dot children do end build tree. We're gonna build the tree for struct no for the child. So this is kind of an approach. So let's gonna print struct dot data, something like that, and let's see if this passes or not. Make test. Okay, so what is the output? What? The output is nothing. The output is nothing. Okay, because I haven't called this function structure. Okay, so as you can see, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This is the traversal of this tree. So first we go visit this first the root node, which has the value of 1 and 2, 3, 4, 5 accordingly. So okay, now we can insert the tree nodes. Okay, got it. So how are we gonna add this thing? Tree node. Wait a minute. So this is the tree node. Um, Now we have to mimic this thing. Hmm. So we need data, right? Let's just try a simple approach first. Then we're gonna generate the tree randomly. So this is the root node, right? So this is the root node, and root node add child, root node add child. The address is 1, and we will add the 2. Um, Address is a string. What? Oh, this should be an integer. Okay, that's perfect. Now we have to add more childrens to it. 3, 4, and let's just test this out. Print vim.inspect root node. So this is the structure that we are getting. So this is the root thing, which has the data 1. Then we have children's array, which do not have children because this is correct. Okay. Then we have data 3 and 4. So, okay, this is perfect. We will implement this thing later. Currently, the test literally passes, so we can move forward with the structure. We will improve the quality of the test later, but currently we have to just finish this plugin. So struct.lua. So now we can add the childs where we want. So that's it. Now we have to just make a store.lua, which holds the meta information of every key. Okay, then every store should have some kind of a counter. So, so the count is 0, and we have a function m dot gen gen key, or you can say gen meta key. Let's make it simple. So gen key, it will return an integer. What is this? It will return an integer and count plus plus, and we will return the count. So this is the whole thing, and there are some getters and setters also. So m dot get, so in the get we have a key, and in the key we have this thing, the integer, and this integer will map the things, so we can just count and the store, right? So we're gonna store key. Perfect. So that's it. Now we just have to make a setter. In the setter, we need a key. I mean, I think we don't need this logic. We can just merge this logic in here. So we have a table, key integer, and this will be a table. And in this table, we will assign count plus plus and store count is equals to that table, and we will return the count. So this will return a key also. So that's it, I guess. This is all we need. So we don't need that thing. Perfect. So this is the whole story of store. Now we just have to integrate this tree structure with this EUI. So this is the tree. Let's rename it to tree node is equals to filer struct. Okay, and where we are creating the instance of the filer view. So here it is. Now we just need to generate a tree. Hmm. So this is the filer view, new, current working. So this is not a problem. So where is this open function? So this is the open function here. Okay. So let's create a tree node here. Self dot tree node tree node is equals to Actually, we can assign this at the time of creation. So these are the filer view thing, and this is the filer view. Okay, let's just add a tree node, and let's just format everything here like that. And this will be a filer tree node. Okay, so perfect, I guess. Now, okay, where is this new function? So this is the new function. Now we have to assign a tree node here. Hmm. So now this is the time to import the store here. So require store. So this is the store, and now store dot set. And what we gonna set here? Hmm. Wait a minute. Uh, Tree node dot new. So we will create a new node with the data, and data will be integer value which is given from this setter function. And this setter function will hold some kind of a data, and the data is simply the name. As you can see, we are not storing the name type path in the tree. We are just storing the integer value of the key, and every cluster of data is storing in the store. So tree is not the uh, you know tree is now just a simple data structure uh, with the node as a number. So there's no complex structure in every node in the tree. There is just a simple integer value on every node of the tree. Every information is stored in the set. That's why the this new architecture uh, will be easier to understand and easier to extend. So we need fn.f name modify with the ops.cwd and with the t flag. So we need a type. So type always be a directory, because if we are opening if we want to open a file tree, then there should be a directory, because if there is no directory, then filer cannot open that particular path, because if that is a file or symlink, then neovim can automatically open that open that path. If that is a directory, then filer need to take actions. So we will just make every root a directory. So the path is simply so the so the path is ops.cwd. I guess that's it. Yeah, that's it, I guess. Now we just have to expand the things in the tree. Hmm. Okay, we just have to add one last thing in the tree. This is not related to the comparison. It's just the open property, nothing else. Because we just, you know, need to know while traversing that should we go deeper in the tree or not. If the directory is open, then we go deeper in the tree. Otherwise, we stop the searching of the elements. So that's the only thing. And the root directory always opens. Okay. Okay, we don't need that thing. And how are we gonna pass that thing? Um, Okay, I want to open this thing. Hmm. So that's an interesting thing. Like, should we pass the value or should we um, toggle the open property? Let's just make a toggle property for now. So the tree node toggle open, and this will just do self dot open is equals to not of self dot open. I think that's the whole thing that we need. And by default, every node is set to false. That's it. Okay. So, so let's create a tree node here because we need to reuse that thing. So let's grab it here and put it there. And this is the tree node. There we go. And let's just node, tree node toggle open. So that's it. We create a root node and we toggle it to the open state and we assign it to the file tree instance. Perfect. Okay, now we have to just open the, you know, we just have to expand the tree when the filer window is open. So when the filer window gets open, we need to expand the tree. So how are we going to expand that tree? So let's make a function for it. Here, maybe here. Let's put it here. Function, filer, preview, update. So we will update the tree according to its states. All right, so how are we going to update that thing? So we need to just go through each of the node and we will, you know, we will go to every possible children that we can. So self dot self dot we need a dfs function which takes a node, and that node is just a tree node. And if node dot children, then we will continue dfs for every child I pairs of node dot children, and we do end. Okay. That makes sense. Well, instead of this, we check the open property, if the node is open or not. So if the node is open, then we pass through, we will traverse through every child, and DFS to the children, right? This is the whole thing. Okay, and now we have to use this DFS function on self dot tree node. So this is the simple DFS function which will traverse all of the available nodes in the tree. Now, by going every node, if the directory is open, then we will list the items of that directory. Are you getting my point? So we have a fs module here. So now we're gonna, if we reach to an existing, you know, if we reach to an existing node which is open, then we check its metadata. So this is the metadata. And how we gonna get this metadata? It is easy. We just get from the store. That's why this new architecture is so easy to implement, and every algorithm and every line of code is so simple. So what you have to do is just provide the data, because this is the key of store, and we will get back the data that we need. So now we have to check if the path is valid or not. So stats is equals to uv. Okay, we don't have uv. Let's make uv here, vim dot uv or vim dot loop, right? Best dot loop, list dir. Okay, we don't need uv right now. Actually, the list dir function or automatically can handle that thing. So we will get the items and the error from the fs dot list dir function. So we will pass the metadata dot path. That's it. Okay. So if we have error, then we return. We don't have to go. I mean, we don't have to go further, because the path is already doesn't exist, or we can't list the items. So we will stop the traversing. Otherwise, if we have the items, then we will compare the lookup table. I mean, let's make a lookup table. Let's call it a scene, right? I think we don't need that, because the tree structure is so simple. We can directly assign the children's. So a node is kind of boring name. So let's make a complete name, a tree node. Okay. And the tree node children is equals to vim dot um hmm return vim dot iter items find. So let's find out if any of them has item, if any of the uh, equal to child dot data, right? Child is equals to a tree node, actually. So that makes sense. And this item is just any uh, any type. So we are filtering the children's array, right? We want to remove the children that that doesn't exist anymore in the file system. So um, so this is the children, and every children is a node. Hmm. Wait a minute. So children have a data, right? Okay, okay, okay. So this is the right thing. Store.get child.data. So this will point to the, you know, this will point to the metadata of this key value, and we will check if the path and type, they should be equal, right? And item dot type is equals to the store dot child dot path, no, child dot data dot type, something like that. So this will filter out the children's that doesn't belongs to the file system anymore. And actually, let's iter function. Let's convert this into the iter function, and this is the children's, I guess. So node free node dot children, right? So we don't need that thing. We can just directly filter out that thing with the function, and that function just need, I mean, this iter function is much better than the vim table filter function. So what are we doing here? This is the child. Perfect. Child. Okay. Correct type definition. So if we have any kind of, okay, if we don't have, so let's put a not operator here. So if we don't have any item related to this child, then we remove that child, right? So this is how we can filter the children's table. All right. So the next thing is to add the remaining childrens that are currently joining the file system. So if there are some childrens that are not in the tree right now, so we have to add them. So how are we gonna add them? Mm, let's go each of the items, right? Let's go each of the item, and then we can find vim dot iter. What is this thing? It's nice to see some live nvim plugin dev. Okay, then just enjoy, sit back and relax, and let me finish this module first. And by the way, Knived, welcome to the stream. So vim iter function, vim iter function. So we need tree node dot children find. So we need to find a function, or I think we don't need to find. We just have to check if that exists or not. So if any of the thing is exist, um, so we just have to return the thing children. So we will return if the children, you know, children dot store dot get child dot data. Let's get the type definition from here and put it here. And if the data dot path are equal to the item dot path, right? And store dot get child dot data dot type is equals to the item dot type. Same condition, we just check if any of the thing is happening. So we can wrap this thing into an if condition. So if we have an item which is not in this children array, then we will have to add this thing. So tree dot add child. So we have to add this child. All right. So what is the you know address of this? The address is just simple tree dot data. So this is the address of the node that where we want to add the children. Hmm. And the data should be a key, right? An integer key. So store dot set. Now we have to set the table, and we will add that item. That's it. That's the whole thing. And by the way, address. Tree node dot new. We need to provide the data here. Anyways, wait a minute. Tree new node. New node is equals to tree node dot new with the data flag. Um, hmm, and the data is just simply store dot set item, right? So we don't need that thing. Actually, we need the key actually. So store dot set the item. And now this is the data. So this is the key, and now we can new node. And before doing that, so should we open this thing or not? If we don't have to open this thing, then we don't need extra variables like that. Something like so. So, and we have to provide the address. So address just simply tree.data. That's it. That's it. Let's put this here. Okay, so we filter out the existing children's, and we add all those children's that are not currently in the tree, but they exist in the file system. So perfect. Now we will, if the tree node is open, like if the tree is open, then we will gonna, wait a minute. This thing has to be checked first. So we successfully add this thing. Hmm. Actually, we will not traverse any children if the directory is not open. So if renode dot open, I mean not pre open, then we will return from the function. We will not enter in the directory, right? Okay, perfect. So this will update the tree according to our need. So what we're gonna do now is just to self, whenever we open the window, we have to update the children. I mean, we have to update the tree. And after updating that, I want to debug the thing, like how the structure is looking. Self dot tree, right? So let's test this out. Not in the floating window. Let's open another window and let's spoiler. And you can see in the bottom right corner, you can see here the whole tree structure is here. Wait, what? Wait a minute. Okay, I know. What is the problem? You know where you have filter this thing? So we have to do it some like to table. Otherwise, it will return an iter class. Otherwise, it will return an iter class. So not a problem. Hmm. Can I do that? Okay, perfect. Okay, so perfecto. Let's try one more time. Um, I think this time, okay, this time everything is fine. You can see the things are correct, I think. Okay, now we just have to convert those tree with integer values to our actual file system entries. And how are we gonna do that? Let's just go to the UI part, file tree UI, and there we go. Hmm. Actually, we can make a function here. Let's make a function here and file tree view um, to table to table. Let's make a to table function which will return the file system kind of architecture, like a human readable format thing. So this will return this thing. So file tree view will give the table format of the existing tree. So how are we going to do that? So let's suppose this is a table that we have to return. Wait a minute, guys, just wait. Hmm. We can do this by ChatGPT, I guess, but I don't think ChatGPT can, I mean, can do that because this is our code. Hmm. All right, so get table. So this will take a node, a tree node, uh, tree node. So this will take a tree node, and this function is responsible for returning the uh, Lua table for particularly that node. So what we're gonna do is just to if a tree node that open. So if no, then we will return a table. If the node is not there, then we will return the thing. Wait a minute. What I open? Anyways, so if the tree node is not open, then we don't have to go in there, but we don't need to check that thing, or we have to. So we will not go there. So what we will return? So we will return the store dot meta meta items, I guess. So store dot get tree node dot data. So I think this will return the things that we need, and then we can follow this approach recursively to build up our whole table. So if the directory is open, then we have to go through every better file manager. What are your selling points of making it better? Um, uh, Actually, guys, I explain every single thing in my previous streams. So sorry, guys, I can't explain everyone in the every stream. So if you have some time, then you can watch the previous stream, just a little part, and you will get an idea why this plugin is a little bit better than what others are providing. Currently, the best file manager, in my opinion, is the oil-nvim, and this plugin provides all the functionality of oil-nvim. On top of that, it also provides the file tree view. Uh, it's that make sense? So let's continue moving forward. So understandable, maybe add that timestamp to read me. Yeah, that makes sense. But currently I'm so busy on implementing, improving the code base architecture of this plugin, because the plugin is ready to use. You can just install and use it, but it's not stable. That's why I'm fixing the architecture of this plugin, so that contributors like these contributors like this one and this one can, like there are also so many contributors that want to contribute in this project, but the code base architecture is so, messy, that it is so hard to understand how the underlying concept is going on. That's why I'm just refactoring the code um, to a more professional level, so that anyone can contribute to this project, and we can make these kind of timestamps, no, these kind of goals. We can achieve these kind of goals in shorter amount of time. Otherwise, the plugin is completed. You can just install and use it, but be careful. This is not in stable form. It could raise some errors or issues, and when we talk about the file system, then there are some important things that you don't want to lose in, I think. So just be careful to use this plugin right now because it's not that stable. But don't worry. Uh, uh, we will working so hard to make it stable, and just you have to wait 1 week or two maybe, and the first release of this plugin is going ahead, I think after 1 week, in my opinion. And by the way, if you feel like my English kind of broken, so please sorry, because English is not my first language. That's why I kind of, I mean, you know, kind of stuck while talking about something. Anyways, let's complete this uh, refactoring stuff. Gotcha. Efficient coding while streaming must be impossible while answering question. Yeah, yeah, yeah. You can understand that. And my current goal is just to complete this plugin as soon as possible. I mean, at least the code base refactoring. I just want to complete the code base refactoring as soon as I can. Okay, so anyways, so most of the people in the world don't have English as their main language. Yeah, that makes sense, but they can speak that language. Uh, anyways, let's moving on to the children's. So we will have to process every child, right? Um, um, in I pairs, I guess. So prenode dot children, right? So child. So we will have to traverse. Okay, got it, got it, got it. Let's prepare a table. I mean, sub table like that. We can take this thing out, put that here, and return the sub table, because now we can assign some childrens to it. So sub table dot children, children equals to a table, and then we can table dot insert sub table dot children, and we can recursively call this thing with the child. So I think, according to my programmatical mind, I think this is the correct implementation of converting a tree into table. I don't know. Maybe I'm wrong. Let's try this out. Get table of the self dot tree node. Let's see how things are going. So instead of inspecting the tree tree node, we will just self dot to table. Is that make sense? So we are getting nil. That's annoying. To table. Oh, okay. Oh, okay. I think I have to practice some data structures. So let's ask our friend, the DeepSeek. I think I have to provide the whole code. Fix my um wait a minute. I think my mind is saying that you should return the subtable regardless of the children's. So let me just try one more time. And wow, I think I know some kind of a programming. You can see the root node name is the filer.nvim, the path, and this is the type directory. And you can see there are some children's, and this is so easy. Okay, we are successfully able to do that thing. Man, this is kind of a difficult thing, I guess. No, or am I just? Anyways, let's go. We successfully managed to create table. Now we can render that table into the window. So okay, we will update that thing. So self.update. File tree will get update. Now we can return the table to the render function actually. So that's the cool thing. Now we're gonna go here and you will see a magic in just a moment. Let me just try that thing. 1, 2, 3. Oh no, not now. There's one more thing is missing. Give me 1 second just because we need a meta key also. We need a key to uh, I will explain everything. Just give me a second. Um, so we are getting the data here. Okay, but there is one more thing that we have to attach. We have to attach the meta key here. So subtable dot key is equals to tree node dot key. Key, or what you can say, data. Sorry, it's not key, it's just data. And we will append the children here like that. Okay, let me just clear out some things. So let's return an empty table to the render function. Pretty cool. So now we can see the magic happening. If everything is going according to plan, you will see a file tree structure in front of your eyes. So let's self.to table. Is there anyone watching? So 4 people are watching. So just see, or we will see an error, I guess. Nothing? What? Okay, give me a sec. Something is wrong. Okay. Now what is happening? I think UI dot. Okay, now I got it. I have to import the UI to render the things. I mean, views UI. Sorry, I just forget about this thing. So file tree, we have to self self dot render, no, to table. That's all. and we can pass children as a table. So let's see if this time it's working or not. That 1, 2, 3, boom. There we go, guys. This is the whole listing of the uh, this is the items that are exist in the current working directory, which have icons, names, and directories are marked as blue, and you can recognize them by the icons. And by the way, these icons are coming from the um, mini icons plugin. So just tell me how you like that thing. Okay. And by the way, you can open the filer in any kind of a directory, like in my home directory, maybe. Let's try to open that thing. You can see my home directory contains only one user, which is me. And let's try to cwd into home workspace and kind. We can provide a kind also. I'm gonna split it in the left direction. You can see we are splitting in the left direction, above direction. I don't know that you can see this line. This is a split window, and this split is according to the configured width, configure height in the configuration of this plugin. So there are some dynamics to on the plugin startup. Now there's one more thing that we have to do. We have to arrange them in the order. You can see some directories are down the some directories are in the end of this list, and some directories are on the top of the list because they are ascending lexicographically. If you don't know, then you can Google search what is the lexicographical order, but they are sorted in the lexicographical order. So, but we don't want that thing. So we need all the directories first, then all the files and all the symlinks. Okay, so we will render that accordingly. Okay, so how are we gonna do that? Hmm. That's kind of a challenging task, I guess. We just need to sort them, nothing else. I think at the time of table creation, we can sort them like right here. So after appending the childs, we can do something like vim dot, or you can say table dot sort subtable dot children's. After appending each children, we will sort them according to our defined function. So a and b with the children's. So how are we going to sort them? I have a sorting function already written in my files, which is in the node.lua, I guess. Yeah. So we can cancel sort. So we have this function. Let's copy that thing. That's all. That's all we need, guys. That's all we need, I guess. So let's try to reopen this thing. And you can see all the folders are top of the list, and all the remaining files are below the directories. And all the directories are mutually sorted in lexicographical order, which is I think the correct order for a file tree. And if I open the neo tree, you can see the same structure is follow here. So there we go. And by the way, we have to enable the numbers and the line numbers because this is the buffer. So we have to need some kind of a reference. So how to enable the numbers and the relative numbers? The numbers and the relative numbers are a window thing or a buffer thing. So vim lua vim.vo dot number or lua vim dot wo dot number. Okay, this is a window thing. So let's enable the number is equals to config dot get this thing. Do we have them? No, we don't have thing. So we have to do it ourselves. No, this is not a thing. Values dot wins. Oh, come on. Do we have define in the configuration? Okay, we don't have any definition for numbers and the relative numbers. So, okay, we will define them later. Don't worry, but let's make them true by default. Relative numbers to true. So now you can see numbers and relative numbers. Okay, these are the numbers and the relative numbers. And by the way, you are thinking about like what I'm doing. I mean, what I'm just doing about the meta key. Meta key is exist in this buffer. You want to see it? Let me show you. Conceal to 0. You can see here, these are some numbers assigned to every file item. These are the hidden characters that buffer-based file managers like OLNVim uses this approach to store the meta information about every file system item. So whenever anyone presses enter, something like that, then we will parse this meta key and calculate the operation according to the meta information from this key. So this is the whole approach, and we will just hide them to conceal by setting up the conceal value to 3. You can see the conceal value for this window is 3. That's it. And we can define the syntax here. So this is the syntax that I'm using for filer meta key. This is a regular expression. You can see there's slash d. D means the digit. So if any digit with a space at the end of the line, we will conceal that line. And conceal means we will make it invisible. That's it. So I think the stream quality is quite good. Perfect. So we don't need a deep seek anyways. So can you guys hear the music? Should I raise the volume or is that okay? Or we can move to the next step of this plugin development. Just let me know if you want to raise the volume for the music. Right, so let's go back. Okay, now this thing is done. So let's just commit this thing out. So we remove the algorithm, we remove the structures folder. We don't need that garbage. And we remove logger, we remove the test for the list. And there's one more thing I think I removed. Okay. Refactor, remove unnecessary modules to simplify things. That's it. And there are some more things like window. What we are changing in the window actually? Okay, we add the user commands. So feature, add user auto commands, support to win.lua. That's it. Now this is the file tree thing. So the file tree thing have some actions. So the regex is updated. Okay, this is the structure, this is the store, and this is the UI. That's all, I guess. Hmm. So okay, let's commit those things. P2 uh, integrate new simple what we call this type of a tree, an array tree, I guess. An array tree with the file view. I mean file tree view. Perfect. These two files, I'm not gonna commit them right now because they are not completed. So let's go to actions and we have to complete this action. Now this function will get smaller. Okay, so we need to extract the key, the information about that thing. So let's store requires filer store. So this is a store. Now we just have to print vim.inspect, and we're gonna inspect store.get what? Why don't I mean, give me auto completion. Store.get. Oh, this is why I'm not getting the auto completion. I don't need that thing. So store.get key. So this should give us the metadata of the underlying item. So if I press enter on any kind of file, you can see on the bottom right corner, this is the meta information about the file system item. Okay, so guys, do you have any question about the progress so far? I'm happy to answer your question. Otherwise, I think I'm gonna go sleep. It's kind of boring if I'm just coding and not talking so much. Anyways, just joking. I want to complete this as soon as I can. So now we have the meta information about every single item. So what we have to do is just to uh, toggle toggle the thing, toggle some kind of a specific parent. Hmm. So we have to toggle some specific parent, right? So we can implement that thing. Wait a minute. Just struct or wait a minute. What I test this? Let me just name it struct. Perfect. Okay. Struct, right? And let's just provide a thing here. Hmm. I want to toggle the open property. Hmm. How I'm gonna open the toggle, I mean, toggle the open property for a specific parent. I think first I have to find this node. Hmm. And then I can toggle that thing. Okay. So let's implement a tree node and find address, and that will return a tree, I mean param addr, an integer value, and this will return and node, right? So how are we gonna find that then? So if the self dot data is equals to addr, then we will return the self, right? Otherwise, we will go each of the children. We will go through each of the children like child in I pairs self dot children do end, and if the child hmm I think I don't waste I think I don't have to waste time here. I shouldn't waste the time here. Let's just complete this simple thing with the deep seek. I mean, complete the find method. So this will return the desired node. Okay. Okay, that makes sense. So we are going through each of the children. If we found it, then we return it. Otherwise, we return a nil value. I'm kind of close, but anyways. And we can refactor this code also. Hmm. What we are doing here, we are just adding the child. So let's just find target node is equals to self find address, and then if target node, then we can add the target node child the data, I guess. I mean table dot insert target node dot children m dot new data. I think yeah, I think we are doing correctly. Perfect. So this is the correct approach. You can test this thing out by open the filer window. Perfect. So everything works smoothly. Now we have a find function also. So we can toggle the property in the actions. So this is the actions. And in the actions, we can just find the node. So tree node is equals to view dot tree node find the key. We just have to find the key, and we just have to toggle that thing. So we don't need the whole thing. We just toggle open property, and let's update. Or you can say api.nvim exec order commands events user pattern. Pattern should be, what is a pattern? File init. So the pattern is user auto commands. So let's add a user auto command here, and in this we have pattern of file tree view refresh that thing, refresh, right? So this will refresh the thing, I guess. We will name it correctly later, but anyways. So this is the event that let's copy that and let's paste it here. I think that's it. That should do it. And do we have a thing? Do we have a thing called? Wait a minute. This is not the action that I want to call. This is the self dot refresh. This is the self dot refresh, I guess. And self dot refresh is not implemented yet. So let's implement that function. It's just a simple function, a tree view refresh, and that will return a function, and that should return a function that will self dot UI self dot when dot UI render UI dot file tree self dot to table. I think that's okay. Let's just test this thing out. What? The whole table is gone. I didn't do anything. What is happening? The whole table is gone. Why? Oh man. This thing literally sucks. Hmm. So what should I do now? I think I should just print inspect self to table. Let's see what we are getting. If I press enter on the plugin, then let's see what things we are getting here. Plugin. But why this plugin don't have children's? When I press enter, should be there should be some more children's there. There's supposed to be some children's. Anyways, let's just lua equals require filer dot view dot store. I mean free dot store, right? I don't have a debug function in the store. Store. Let's define a debug function. M dot debug, and that should end m dot inspect store print. So let's just do that thing one more time. Let's press this. Let's clear the messages. Let's do debug. And okay, it's not just tree, it's a file tree. Plugin file.lua. Hmm. Hmm. I think I know the problem now. The problem is just file tree init. The two table function, when we are doing it here, where is this thing? Yeah. So we have to pass the children's actually. So let's just do one more time. Plugins. So nothing is happening. Interesting. Is this re-rendering or not? Hmm. So this is the render function. So let's just add a debug statement to the render function. I mean, hello. Okay, this is the first hello that you can see here. If I open the message, you can see there is a hello. Okay, if I press enter, you can see there is another hello. That means the rendering is happening here. I press enter so many times, that's why there are so many hellos. The rendering is going correctly, but the problem is the tree is not updating. Oh, I know. Because tree is not updating, we need to update that thing before rendering it. So let's just do that thing. If I press enter this time, nothing happens. Hmm, what? Plugin folder should have some children's. I mean, it's supposed to have some children's. I mean, you can see here, plugin folder have a file. So this is supposed to be working. Hmm. So this is the key. Did you guys see any bugs or something? Like, I'm thinking that the update function is not correctly updating the nodes, actually. Did you notice something that I'm missing? I mean, I'm kind of stuck this time. Okay, just give me a second. I need to drink some water. Oh, so we are back. Okay. Let's just ask from the DeepSeek. Check the update method that is that it is it really updating whole tree or not? Let's analyze update method in all class. Correctly updating the entire tree. Current implementation, potential issues. When nodes, open nodes, close nodes, and their subtrees won't be updated. This might be an intentional for performance, but could lead to stale data if directories were modified while close. No, that's not a problem. Add force update. Hmm. I think our update function is okay, I guess. So we are starting the DFS, and If the node is not open, then we uh, then we stop our traversal, and otherwise we will get the metadata and we will list the items. Okay. Okay, now I got it. Now I got it. The real problem. File UI. The problem is in file UI and not in the, you know, the problem is not in the file tree traversal. It's just the problem with the rendering engine. You can see this is the only, I mean, this is level 1 depth structure, not the dynamic structure. So let's see if DeepSeek can do that. Can you modify the following uh, rendering structure to for nested directories. Let's see if it understands correctly. Here's a modified version of this rendering structure. So let's see what changes is made mating of. I'm gonna just copy paste everything because I don't have enough time to check everything. So let's copy that thing. Looks like there are no errors. Redefined component. Huh. That means we have a component above us. So let's just do cm form that thing. Okay, perfect. There is no diagnostics, so let's just test this thing. Okay, looks like, but why? Why is adding auto indentation? I don't want right now. No, not the indentation. I just don't want the markers, actually. I don't want the markers. So don't give me that. So I don't want icons here. Hmm. Uh, Man, let me just undo everything because I think DeepSeek is. Let me just print that thing. One dot inspect table. Uh, so this is the thing, not a problem. We can just clear the messages. If I press enter on the plugins thing, there should be a filer.lua somewhere. Why? Pilot.lua is not there. Um, File tree init update. I want to see which node. Store.get data, tree node dot data, and that's it. I just want to know which tree node, which tree node is not open, right? Let's see. Um, okay. So if I press enter here, let me wait a minute. Wait a minute. Everything is just on. So if I press enter here, let me just message here. What? Nothing is printed. So you're telling me that um, then every node is open? Geez. No, the nodes shouldn't be open. The nodes are closed by default. Um, struct. Not this struct. Yeah, the nodes are closed by default. Then what's the deal here? Why this view is not updating? Any idea, guys? Any kind of help would be appreciated. Store, store. Hmm. Are we? Wait a minute. Something is wrong with the DFS function. Wait just a minute. We are not going deep, I guess. Yeah. So now we have to go each of the items in the, I mean, each of the children in the self, I mean, free node dot children, right? And now we have to run the DFS function on the child. That makes sense, right? Let's just test this thing. Will it work or not? So we don't need the print there. Okay. Okay. We need some debugging. That makes sense. So these are the childrens that we are not visiting because they are closed by default. Perfect. Yeah, that makes sense. So let's open one more time and clear the messages. And when I press enter, let's see. Do we have plugin? So this is the directory, and we are, this is not open, but I just opened that thing. Why? Why is this thing not open? I mean, free node dot open, something like that. Do that, clear the messages, press this, open this. So this is not open. Let's go to the plugin. So plugin is not open. Interesting. So this is the type directory, right? And we are refreshing the view. You find that, open to toggle. So wait a minute. Wait just a minute. Node, node. Dot inspect, test node, test node. Let's see. Print. Let's just comment this thing out. And when I press enter, the node is nil. Wow. So the, oh shoot. Now I got it. Why this is not working. Because the find function, oh man. But why? Why we are unable to find that thing? Why? Just tell me why. This is a nil value. Oh, this is a nil value because we know toggle will open. A nil check, we will do that later. But let me just take up the node. As I press enter, you can see the data. The open state is false here. Okay, let me just open that thing here. Okay, this is the thing. Now the state is open. Okay, the state is open. Then what's the deal? What's the deal, man? Hmm. Hmm. Uh, Camerado and NT. Welcome to the stream. We are just finish off the rendering mechanism, and we are just about 80% completion of refactoring of the whole code base. About 80%. The work is done. I'm just talking about the refactor of the whole code base. Nothing like the first release of this plugin. So filer.lua. Hmm. Sweet man, good luck. Gotta run. Okay, thanks for saying hi. Hmm. How much time? It's about 2.5 hours. I think, guys, we should continue this debugging session on tomorrow's live stream. I think That's kind of a too much for me, I guess. I don't think I'm able to find the bug right now. I'm kind of tired. It's about 2:30. I mean, 2.5 hours. Okay, so we will wrap up the stream, and we will stream tomorrow and complete this rendering mechanism. And probably I will complete this off camera. Not sure if I get the time to complete it. I will complete that. So, so guys, have that's it for the stream. Good night. I have to end the stream right now. So take care. Bye bye. And we will meet in the next stream tomorrow.